Summer's coming and lots of us mathematicians are looking forward to the test match between England and India at Lord's Cricket Ground in London. Cricket is normally played on flat surfaces, but Lord's slopes by several feet from one side to the other. And this is always held to have an effect on the behaviour of the ball as it bounces off the pitch. The commentators will say that the bowler brought the ball down the slope into the batter, or that it moved away from the batter down the slope. Most batters will practice for hours and hours and hours on completely level surfaces. They watch the ball as it comes from the bowler's hand down to hit the pitch and then onto their bat, and their reflexes are tuned to flat surfaces. So particularly at the start of their innings, when they're playing on an inclined surface, they may play down the wrong line and aim at the wrong point very slightly. So how big might this effect be? Well, we've seen that the pitch slopes by about 1% from one side to another. You can make a simple model using the coefficient of restitution of a bouncing ball coming off a slightly inclined plane to show that the sideways deviation would also be about 1%. If the ball lands 3 yards in front of a batter, that's 108 inches, that's around about an inch. And around about an inch is enough to take the ball from hitting squarely in the middle of a bat to hitting near the edge, or worse, hitting near the edge to catching the edge and nicking off at slip. So this is an interesting question because the ball also moves sideways for all sorts of other reasons. It swings in the air, it bounces off a seam when it hits the pitch, and the pitch might just be a bit uneven. How do we find the effect of the slope from all of that? We would have to do a statistical analysis looking at lots and lots of balls and lots of dismissals in particular to see whether at one end there's an extra quota of catches at slip and whether at the other end there's not so many catches at slip because of the slope. So there is a question for the statisticians to ponder.